the web service. And that stub is actually going to be in the Silverlight zap file as well. So the other option we've got is if we go back to our Silverlight page, we can actually just directly get the URL to the zap file, doing something like a view source. And then we can issue a direct request to that zap file, pull it down, and then we can decompile it very easily, just like you can decompile any other .NET application. So if we actually make a direct request to that, we should be prompted to save it. So we can just download that directly to, I'll do it to my desktop here. And then once you do that, you can actually just open it with WinZip or 7-zip. If you open that up, you'll see the different files that are in the zap file. The XAP or the zap file is basically just a zip file that includes a configuration, whatever configuration information Silverlight needs, as well as the .NET compiled DLLs that the application uses. So if I just drag this DLL out, and then I can actually open it up with .NET Reflector. What you'll see here is that within that Silverlight, within that DLL, you're going to have a service reference that's going to basically have all of the metadata that you need to talk to that web service. The way I like to do this is there's a plugin for Reflector called the file generator that a lot of you may use. And what it does is it makes it really nice. You can just right-click on the file and hit export, which should be an option here. My machine's kind of hung for some reason. This isn't good. Well, we'll give it a second. There we go. So when you right-click, if you do an export, it'll go ahead and, I think you have to do it on here. It'll ask you where you want to export it to. And the nice thing about the file generator is it generates a Visual Studio project with all the decompiled CS files. So I've already done that, and I got it open here so you can see what it looks like. This is really a much better interface to be looking at this stuff with instead of the Reflector interface. And you'll always see in your service reference that you're going to have the service class that has all of the endpoints defined here. So the interesting thing is that while our Silverlight application is only using the calculate method, you can see here I added another one just called test echo that's actually not being used by the client. So the nice thing is, irrespective of whether or not the Silverlight client is using these methods, the interface to call them is going to be defined within the zap file anyways. So this can be a pretty effective way of pulling that metadata as well. And then the last way that you can potentially get metadata, which is a new one, is known as WS Discovery. This is actually still in beta. It's coming out in the version 4 of the .NET framework. WCF is going to support it. And essentially what this is this is an open protocol that's been around for a while that allows web services to dynamically discover each other on the network. So if an address changes or something changes in the middle of the day regarding one of these services, the web service can announce the changes and broadcast it to the network. It works over UDP. It's multicast. So, it does run on 3702. And the way it's intended to work is these web services just broadcast messages to all the different web services on the network. And there's 4 different types of messages. There's a hello, a bye, which are pretty self-explanatory. And then the ones from an attack perspective that would be useful are the probe and resolve methods. So you can actually start probing and searching for different services. I haven't seen this at all in use in practicality, simply because it's probably, I don't think anyone's going to really use it widespread until it's out of beta. But certainly some cool stuff, and I think down the road this is something that we're going to start to see a lot of once it comes out of beta. So that's sort of the Silverlight angle. The other thing I want to talk about is some of the other interesting bindings that WCF has. And specifically, there's a subgroup of bindings that they refer to as duplex bindings. And duplex bindings, as sort of the name implies, allows two-way communication between the client and the server. So not only can the service be requesting information from the service, but the service can actually push data down to the client. So it's really nice for applications where you're just sort of subscribing to a notification and you're waiting. There is an option that allows for the clients to poll at regular intervals, but that's not going to be real time. the true duplex bindings are pretty real time, so the service can then push data down to the client. Now, the interesting thing about the duplex bindings is there's one specifically that operates over HTTP. It's called the WS dual HTTP binding. And this one really caught my eye when I was looking at it from a security perspective, because HTTP is sort of a one-way protocol. There's a request and a response. So the way they've implemented the dual binding that runs over HTTP is that the client actually opens up a web server port on the machine and listens for incoming messages from the service. So that, of course, is a little bit alarming when you think about it. It's like, wait a minute, I'm opening up a port that's running a web server. It's a lightweight web server. It uses the same API that IIS uses. It's the Microsoft HTTP API. And really, it's specifically there to receive these incoming callback messages from the service once the communication channel's been open. And the way it works is there's a create sequence request-response process that occurs at the very beginning of the conversation to set things up. And this is really where the interesting stuff happens. The first thing you do is you make, as a client, you issue a request to the service, and the action is going to say create sequence. And you're going to include a reply to URL, which is going to be your host name and the port that you are opening up to receive the callbacks on. So in this example, it's client. I'm using port 8000. The service is then going to open up a new conversation to the client and send a create sequence response to that port. And again, this isn't a response to my request. This is a separate request that's being initiated by the service. It's then going to respond back to the client with a 202 accepted on the, in response to the create sequence request. And then the client is going to send a 202 back to the service. So the important thing to note here is that there's two completely separate conversations going on. One is between the client and the server going over port 80. The other one is between the server and the client going over whatever port the client has opened up for this purpose. So that's how it's supposed to work. If we look at you can sort of look at a scenario now where we've got two machines. We've got a client, and then we've also got a target. In this scenario, let's say I send a message to the web service. I'm client 1, and I say, let's do a create sequence, but reply to target on port 8000. What's going to happen is the web service is going to then initiate a response to whatever machine I tell it, specifically in this case, the target machine on that port, and then it's going to send me back an accepted response to my request. Now, the interesting thing here is that this target did not ask for this request. So that's obviously going to time out. But the nice thing about it, again, from an attack perspective, is we now have a capability to force the servers to start issuing requests to other machines. So we're going to see how this can become a little bit, this is a little susceptible to abuse here in just a second. So now let's open up a scenario where we've got 3 machines. We've got 1 client and 2 targets. So if I send a request to the service that says open up a connection to target on port 8000, it's going to turn around and do the exact same thing it did just now. It's going to make this request to the target on port 8000, and it's going to send me back an accepted message. Now let's say I issue a second request to the service, and I say now connect to target 2 on port 8000. Well, what's going to happen here is the request to target 2 is not going to go through immediately. And the reason for that is that it's still, the service is still waiting to get the acknowledgement back from target 1, which hasn't happened. So, and I haven't looked at the .NET code as to how this actually works, but it appears as though the framework is just queuing these requests, and it's only sending one at a time. Because what ends up happening is only until the connection to target 1 times out do I end up getting a 202 response on my second request, which is when that second request to target 2 comes out. So it's a little confusing, but we'll see how this can be used here in a second to do some fun stuff. So specifically, you can actually use this to do port scanning of sorts, because if we look at the create sequence request, what's happening there is this is the address and port that I'm telling it that I'm expecting my callback on. So if I change that to any other machine and any other port, the web server is going to actually start making connections to that. And the timing of how it responds to those subsequent requests is going to determine whether or not that connection worked. So I'll show you a real example of how this works. I've got a web service running on the VM here on port 88 that's using the dual binding. So this is my create sequence request.